Hello class. In this video, we're going to talk about factoring, specifically difference of squares. Before we get started, let's define factoring. Factoring is breaking down or dividing a number into its factors. Here is the formula that we're going to use for the difference of squares. Okay, these are the rules that we're going to go by before we can use the difference of squares, and here's the steps to solving the problem. Now, before we get started, okay, we're gonna do this example here, okay, and we want to check to see if this example follows the rules before we can use the difference of squares. So, first rule number one is the expression a binomial, and the answer is yes. All right, okay, and is the expression a subtraction, meaning one term is at least negative, and it is. One term is at least negative. Now it does not look like a subtraction, but it is a negative. All right. And are both terms perfect squares? Well, 4 is a perfect square, and 4x squared is a perfect square. I know it doesn't look like it at the moment, but it is. All right? So, now, this does not look like a subtraction, and it's not in this form. So what we're going to do is we're going to rearrange this so it's in this form right here. So 4x squared is our positive right here. So we're going to write that here. Okay? Minus 4. So all I've done is I switch these places right here. But a negative 4 is still a negative 4, and positive 4x squared is still positive 4x squared. Alright? So, if we look, okay, this 4x squared is represented, okay, this a squared is represented by 4x squared. And this b squared is represented by 4. Alright, so let's go ahead and solve this problem. The first step that we always want to do is we always want to check for the greatest common factor to see if it exists. And if it exists, we're going to take it out. So, this term and this term does have a common factor, and it is a 4, obviously. Alright, so we're going to go ahead and take that out first. So what we're going to be left with is, we're going to be left with x squared minus 1. Now how do I get these two terms? So I divided this term by the greatest common factor. I got x squared, divided this term by the GCF, and I got a 1. So at this point, what I've done is I've factored this expression using the greatest common factor. But can we keep going? Right? Sometimes you can't factor it anymore, but in this case, this may still be factorable. All right? So let's check and see if we can still factor what's inside the parentheses. Well, in this case, right, it looks like we can, but let's check to make sure with the rules that we have to see if we can factor this using difference of squares. Sometimes what you get in the parentheses is either not factorable or it's factorable by some other method that we're not going to discuss here. But here we have is the expression a binomial, and I've got two terms here. The answer is yes. Is the expression a subtraction? And yes, it is. And are both terms perfect squares, where x squared is a perfect square and 1 is a perfect square? So yes, we can use the difference of squares to solve this problem. Now let's go ahead and go through these steps to solve our problem. Step number 1 says always check for the GCF. Now whenever we're doing factoring, we always want to check to see if there's a greatest common factor, like we did in the first step right here. And of course we've already done that, so we don't need to do that again. So basically we have the broken down version of this. So we're going to go on to step 2. Step 2 means, well, we're going to square root, we're looking for the square root of a squared to get the value of a, and we're looking for the square root of b squared to get the value of b. Now in the beginning, right, we set this equals to a squared, set this equal to b squared, though that has changed since then. Now we have a new a squared, and it's this, and we have a new b squared, and it's this. Okay? So what we're going to do is, to get the values of a and b, we're going to have to take the square root of both of these values. So if a squared is equal to x squared, alright, we have to take the square root of a squared to get the value of a. Whatever I do on this side, I must do on this side. So I'm going to take the square root of x squared also, and this will give me x. So the value of a is equals to x. Alright? So let's do the same thing for b squared. B squared is equals to 1. Right? So to get b, we have to take the square root of b squared, and I'm going to do the same thing on the other side. So b is equals to 1. Now that we have that, we take our last step, okay, which is to basically plug these values into some parentheses. Before we do that, I want to note that this value right here did not go away. It still exists. Alright, so I'm going to go ahead and write that first. Okay, that is part of our solution. Now, we're going to write these two parentheses that I'm talking about here. Okay, we're going to plug in the values of a and b. And so let's go ahead and do that. So a plus b is x plus 1. Okay, a is x, b is 1. And then there's a minus sign here. We do the same thing, a and b. We insert that, we get a, and we get b. I'm sorry, we did that, messed that up. Not a and b, but x minus 1. Okay? So, that is the factored form of this polynomial. So this is our answer. And if you have any questions, you can rewind, pause, forward, do whatever you got to do so you can review this and see where you got lost. Thank you.